that we have to start today, and directly we will go to chapter number 1. This lecture from the book. So excuse me, focus with me. We will go to something called 1.2. Round of error and computer arithmetic. First of all, I would ask you and ask myself why I need this course. Okay, let's start a little bit explanation about why I need this course. Okay, I will start to open the whiteboard. This one. Okay. Take a pen. For numerical analysis course, this course depends on numerical or number. So we will solve this example based on number or some mathematical methods based on number. Okay. Hujam, we have calculus. So why I need calc? I don't need calc, I need numerical. Okay, I will explain why. Imagine that you have this equation, integration, مثلا 3x square dx. It's easy to solve in calculus, as you know. Now, let's take another example. 3 square x or multiply logarithm x over tangent x dx. It's a little bit hard, as you see. So in calculus, when I solve the examples here, absolutely there is no error. I will get exact answer. Here I will solve, see, solve as approximation, and here we are with error. So here no error in our method. Explain this, not good. Here we have error. So the difference between calculus and numerical analysis, that's mean in calculus I will solve without error. In numerical I will solve with error. So today we'll start with error. Let's know about error, how we can calculate errors. This error can be small, can be big. Absolutely small is better than big. And today we'll talk about errors. So if the error will be small, so this answer will be near to the here calculus method. If this answer or error is big, that means our answer is far from exact answer. Repeat. Calculus and numerical. Those are two methods to solve some examples. In calculus, you know, we have many methods. Answer will take this answer without error as exact answer. But sometimes these answers or these methods are very hard for special cases. Or sometimes there is no answer. For example, you know, for tangent on p over 2 or 3b over 2, there is no answer. Sometimes. So how we can solve this one? We'll go to something approximation, near to. But we jump this near to, not exactly correct, I know. Not exactly correct. But I will solve, we have many methods, with solve with error. In my opinion, in my brain, I want to make this error as small as, and this answer will be like the answer that I will get from calculus. So also inside our machine, computer or calculator or we are using numerical. We have many algorithms that we can apply. You can use, for example, C++, Python, or any language that you prefer to find answers. And for example, in this course, we are using sometimes Excel sheet to solve the answers. So in numerical analysis, we can use some numerical method like algorithms. For example, you can apply these algorithms from Python, from mathematical, for example, software like MathCAD or MATLAB or Excel sheet. I prefer to use Excel sheet. It's easy for all. So this is the basic about numerical analysis. Why I need numerical? Numerical is a course to solve some examples with error. I need, in my opinion, to make this error as possible as small, near to the, and the answer will be near to the exact answer from calculus. So in my brain, I will solve, I need small error. If this error will be very small, that means this answer will be like exact answer that I will get from calculus. Clear or repeat? Khalid, okay. Abdullah, Abu Said, okay. Thank you so much. It's clear for you? Okay. Now, let's start directly. Ahmed, how are you, Ahmed? Good morning, Ahmed. Okay. So let's go to our book. I will talk about round of error. See, we started directly with error, how we can calculate the error. I will jump to arrive to this one. Decimal machine number in your book. Inside our, as I told you before, it's numerical. That means we can apply inside our computer. Decimal machine number, it's a number that we are using inside our computer. The use of binary digit trained to consider the computational difficulties that occur when this is the form here of decimal machine number, or I will use this name, normalized form, normalized decimal floating point form. You know, from programming, that means you have for number, for example, if I have variables, I have integer, I have floating number. Integer like 1, 2, 3. Floating number, that means number with decimal number. For example, pi, root of 2, log of 3, this number. So for integer, there is no error. It's 1, 1, 2, 2, 3, 3, 4, 4. For a floating number, we have pi. Pi it's 3.1417. It's 22 over 7. So we don't have exact answer. So this is called floating point. Did you all of you study programming? Do you have this information about programming? Do you take a programming course? Okay, so you know this outside. Now, so first of all, I want to write this in this form. What is this? This is called normalized decimal floating point form. Keep this now in your brain. I will explain later about this number. How can I write this number? Okay. So this is, first of all, this is decimal number that we're going to use inside our computer. Now let's talk about two methods for summarization. What are those? Let's start with this example. And during this example, I will tell you this one. Okay. Determine the 5-digit. What is this? What is this? What is this? 5-digit shopping rounding. What are those? 4 by number. Okay, let's start talk about this example in details. I will take this example and I start to solve on the white paper. Give me this. Yeah. Copy. Go to the painter. Yes, where are you? Yeah. Here. Paste control. Okay. If I want to solve any example, we have two methods for choose cutting the number, summarization the number. Okay, first our number is pi. So pi is floating number. Floating number, that means I don't have exactly answer. Yani pi, for example, can be 3, 1, 4, 1, 5, 9, as you see here. So the number pi has infinity decimal expansion. So I don't have exact answer for pi. Okay, now the question is, how many digit? What? How many digit? I will write again pi. Pi is 3, 1, 1, 4, 1, 5, 9, 2, 6, 5. How many digit? This one called digit. So digit 1, digit 2, digit 3, digit 4, digit 5. So this is what we saw before about floating number method or normalized for floating number. How we can write this? Okay. Again, to solve this example by this one is wrong. Of why? You have to write in normalized decimal form. So first step is using normalized decimal form. So how we can write this one? See, my friends, here I have a 3. Normalized decimal form says it is 0 dot. So must be 0. Then here D1, D2, D3, 10 exponential positive or negative n. Again, here this one must not be 0. So before dot, integer number, it should be 0. First number or first digit after dot must not be 0. Okay. How we can apply this for this? See, I have a 3 here outside. I will enter inside. See, from out to enter, n will be positive. From enter to out, n will be negative. It's clear for you this? How we can solve? From integer to fraction or digit positive, opposite negative. Did you understand this? Okay. Now let's start. It's pi. It's 3, 1, 4, 1, 5, 9, 2, 6, 5. This is not correct for. I need this the normalized decimal form. So pi will be 0 dot. This 3 will be go inside. So it is 3, 1. Sorry. Okay, mistake. 3, 1, 4, 1 5 9 2 6 5 multiply 10 exponential. I shifted one step, so positive catch 1 10 exponential 1. Got it? Abdullah, Musaid, Ahmed. Got it? Should I repeat or clear? Okay, thank you. Now, after that, we have this number. So, first of all, how can I solve this example? I will write here. First of all, write each number in normalized form like this. Second thing, I have two methods in your book, 5-digit. So I need 5 number after dot. 5 digits, that's mean 5 digits after dot. Okay, let's see here meaning of this one. I need 5 digits, so this is by. I will apply 5 digit for normalized decimal form, not for this. This is wrong. I'll apply for this. So I need 5 digits. 1, 2, 3, 4, 5. But wait, in this way, no, it's correct. Not correct. Here in your book, he gives to me two methods. One method called shopping, another method called rounding. What is different between shopping and rounding? Okay. In shopping, I will see this number 1, 2, 3, 4, 5. What is the sixth number or sixth digit? It's 9. In shopping, I will count 1, 2, 3, 4, 5, then cut. It's 9, it's 2, it's 3, I don't care. Just count and cut. So the floating point form of pi using 5-digit shopping is this 1, 2, 3, 4, 5. Think of this is the answer. So shopping like a scissors. Count then cut. Is it clear? Now, rounding another thing. Rounding here we are using based on 5. Based on 5. What does mean? For rounding, if my number 0, 1, 2, rounding that means here in our example is the sixth digit. 1, 2, 3, 4. What I have to do? Ignore. Forget. Now my number 5, 6, 7, 8, 9. Add 1 to the previous number. Okay. Let's see our example here in our book. Our number here is, this is a floating point. So for a float, for shopping, it just cut 1, 2, 3, 4, cut. Now let's see another case, rounding. 1, 2, 3, 4, 5. I will see to the sixth one. It's 9. 9 here, add 1. See, I will add 1 to the previous one here. So what is the answer? Answer will be by here is 0, 3, 1, 4, 1, 6. 10 exponential 1, or it's equal 3, 1, 4, 1, 6. Got it? So how we can solve? Again, repeat for this one. First case. Write your number in, check this number is a floating number or digital number. Digital number, nothing to do. Floating number, that's mean I have to write this number in normalized digital form. in a normalized decimal form. Then first number, or here it should be 0. Here shouldn't be 0. Take care. Then how many digits I need? I need 5 digits, 3 digits, 4 digits, based on the question. Which method for summarization should I use? Okay, for example, shopping, that means I need 5 digits. I will go to normalized decimal form, count 5, cut, finished. For rounding, no, it's not like this. It's not like this. It will go to check that. For example, I need 5 digits. I will look to the 6th digit. If this is the 6th digit, 0, 1, 2, 3, 4, forget, cut. If the 6th digit, 5, 6, 7, 8, 9, add 1 to the previous digit. Here in our example, the 6th digit here is 9. So I will add 1 to the 5th digit. Number will be 031416. Is it clear? Should I repeat or clear for everyone? Okay. See the answers here. Clear. Good. Now I will clear this. Cancel this. Go to our book again. And we'll talk about something called error. Error. What is the error here? What's the error here? See error here. Here in our book, we have two kinds of error. Absolute error and relative error. Absolute here is, see, I will expand to see the result. Yeah, or the formula. P minus B star. B here is exact number. B star here is approximation number. And you must take an absolute value. For relative, it's exact minus approximation over exact. Don't forget absolute. Okay, how we can apply this for our example? Okay, let's hear. I will take this answer here, just a minute. And I will return back to our example here. Yes. Now, I will solve, or I will find error. So for this one, we have two errors. Absolute and relative. And also for this, we have two, absolute and relative. So now let's calculate errors for A. This one. Okay, absolute. It is absolute error. Sure. It is exact. What is exact? It is a pi minus. I will write pi as pi minus what? Minus what is the green? This is the greenest. This one. This number 3.1415 as that. How we can apply in calculator? Open the calculator here. Okay, it's my calculator, like your calculator. Go here, pi, see this one. So shift pi minus 3.1415. This is the result. So answer will be 9.2653 10 exponential minus 5. Now, for relative error, it is pi minus 31415 over pi. If you get negative, so convert to positive. Again, how we can apply? Just a minute here. This is calculator fraction. Use pi shift pi minus 31415 over shift pi. Right like this. It is 2.9492 10 exponential minus 5. So you must write like this. Here, Jam, can I write 3? No, this is wrong. You have to write by eyes by. مثلا look 2, so you have to write look 2 in calculator. Sorry, wrote 3, wrote look 2, like this one. Write as without any summarization as floating point. Same thing you can apply for another case about for rounding. So for this is apply error for absolute error for shopping and relative error for shopping. You can also apply same thing for rounding, and you can compare the results. Clear? Is it clear for you? Good. Again, you must bring calculator like this. If you don't have calculator, I prefer Casio 991. This is the old version, by the way. Casio 991EX or FX. This is the old version. There is a new version. And who wants this software? I can send to him. It's the correct version. So you can use at laptop if you want. Who wants this? Tell me. I will upload to the system. You can use this like your calculator. Okay. Now let's continue. Okay. Now we have, see here is nothing, just explanation about errors for each cases. For B, it's exact answer. For this one is relative, is approximation answer, and find the error for them. Now, I want to find something about find digital or digital arithmetic operation. Okay. Here you can see something new. For example, if I have two numbers, مثلا x equal root of 2, y equal root of 3. So I will use exact like this. I will write x positive y, يعني root of 2 positive root of 3. And you must open the calculator, this one, exactly, root of 2, oh, not this one, or root of 2 positive root of 3, exact. What's the answer? This is the answer. You can change something like this if you want. Here you have rounding, or you can change to be like this. So this is the answer, for example. Now, if I try to use approximation method, here we're gonna use circle. Root of 2, I will convert to be مثلا 114 something. So if I converted from this to this is now is approximation number. Same thing for root 3. So if I want to apply arithmetic method, I will use plus inside the circle, minus inside the circle, multiply inside the circle, divide by inside the circle. This circle means that I'm using approximation method, not exact method. Approximation, that means either chopping or rounding. Clear? What's the meaning of this circle? Okay. Now let's start with the example. Example is, suppose that x equal 5 over 7, y equal third. See, here also we have a fraction. And a fraction, there is no exact answer. Use 5 digit. This is first. Method is shopping. I want to calculate this. X plus y. So how many numbers here we have? We have this one and this one. So let's take the first one. X equal 5 over 7. By calculator, it's 1, 2, 3, 4, 5, 6. This is normalized form. Same thing for 0, 0, 3, 3, 3, 3, 3, 3, 3. So first of all, write my number in my numbers in normalized form. Now, did I apply or do I apply shopping or rounding? No. Not until now. I will apply shopping. So shopping, how many digits? 5. So it's 1, 2, 3, 4, 5, cut. 1, 2, 3, 4, 5, cut. So first of all, I wrote my number, or I have written my number in normalized form. Second thing, I will apply. How many digits? What's the method? How many digits? 5 digits. What is the method? Shopping method. Okay, let's continue for this. This is the method. Here you can write 0 or without 0. Up to you, because here there is no shifting. If there is shift, you can. Now I apply. I will take this number and take this number as it and put in calculator. What is calculator? This one. 0, 7, 1, 4, 2, 8 plus 0, 2, 3, 4, 5. Answer is like this: 104761. Stay in this case is correct, but it's preferred to write also answer in normalized decimal form. Decimal. So answer also, if you want, you can convert to the normalized decimal form. Now, he asked me find the error. Find the error. Error here is the true value is, see, this is approximation. This is true value. It is 5 over 7 plus third. Okay, here. How can I apply this? Fraction 5 over 7 plus third in calculator, like this one. It is 22 over 21. Now I need to find error. Error in this case is, where is the pins? Yeah, this one. Approximation or absolute error. Exact minus approximation. Exact is 22 over 21 minus this answer, or this 0.10476 multiply 1. And you can find the result from the calculator. It's clear for you, and you can make same thing for every number. So here I have two numbers, x and y. I will apply normalized digital form for each number. I have 3, I have 4, not for final result. First of all, write with me, normalize it for, I will write here, don't forget how to solve. 1, normalize it for each number. Second thing, apply the method. Shopping or rounding. Third, make operation. Fourth, normalize it form again. For result. Clear? In the previous year, some student just make the operation directly and apply normalized form for the result. This is wrong. We have normalized form twice. One before for each number and after for result. Got it? Is it clear for you? Any question for this? No. Same thing here. As I calculate absolute and I calculate relative for each one. Here you can apply it for something. Here I have another example. Here I have u. It is not integer number. It's u, like a u. V like a v. W like a w. So how can I write this number in normalized form? So this number, deal with this number as it. Masala, here I have u. So I will write as floating number. Floating u. 0, 1, 4, 1. Here 9. See 1, 2, 3, 4, 5. Shift inside. So it is positive. How many digits? 5. So this is digital 5. Got? From out to in, positive. From in to out, negative. Here without change. Now he asked me to determine the 5-digit shopping. Yes, exactly. As it. Convert to floating now. Yeah, U and V and W, all of these as floating. So how we can deal with the floating? We dealt before with floating as an integer number. Now we are dealing with U and V and W as a floating. How we can deal with them? Got? How we can deal with them? Okay, excuse me. Now let's continue with this. Now, okay, so see here, I calculate floating. Now, see, I need shopping. So shopping is 1, 2, 3, 4 for this, مثلا. 1, 2, 3, 4, 5. Where is 1? Cut. Here, this number V is 0, 9, 8, 7, 6, 5, 9, 5. I need 5 digits. So see here, it is 1, 2, 3, 4, 5. Cut. This as it's 1, 2, 3, 4, 5. There is no cut. We cut the last one. Now, this is now we are ready to make operation x minus u. X from the previous example, it was 5/7. We found. And u here, we found. So you can make operation. for each one. See the result here. X minus u. Here, as you see, we have two operations. They want to find error or absolute error. See, this is and this is. This is exact and this is approximation. Exact x minus u. So see, my friends, I write x as x, u as u, without any cut. Here 0, 1, 4, 2, 5, so same. Abu Saeed, have you seen? Here I will write the number as this number. It's 11 digit, 5 digit, 6. Write as it with its long. Abdullah, Ahmed, got it? Yeah. Here, the number after cutting. X here will be like this. This number, I will cut the one, so like this. Then make the operation and find the error. Got Ahmed? So here our lecture today. Today in our lecture we discussed many things. First, or why I need numerical analysis course. Numerical analysis course, I need this course for. Sometimes I have problems. I cannot solve in normal calculus or it will be very hard. Calculus, that means there is no error. Numerical analysis, I will solve with small errors. These errors must be as possible as small. So we studied also how we can write the number. First of all, write my number in normalized decimal form. I explained this one. Second thing, I also studied shopping method, rounding method. Third thing, we make operation or we meet the operation. And after that, we write the result in normalized decimal form. Fourth thing, we studied something about error. What is the error? Here we studied two cases. First case was absolute error. Second case was also here as relative error. And I explained also in the calculator how we can use calculator for calculating the error for each case, for this one and for this one. Then after that, we went to find a digital arithmetic operation, and I told you if we have exact calculating, we're gonna use plus, negative, multiply, and divide by as it. If we gonna use as error, we have to put circle. And I explained two examples, one with a fraction, second one with absolutely floating point, and how we can use this floating point for error in this example, as you see, to calculate exact and approximation error. I guess I made the calculation conclusion. This is the last thing here, and you can find the result. After that, you have to go to the end of your chapter, and this book is very nice because at the end of each chapter we have many questions. Masala here, for example, here, perform the following computations exactly using 3-digit. Here, I need 3-digit shopping, arithmetic, 3-digit rounding, arithmetic, compute the relative error for each one. So for each one, that means, masala, for this one, we have shopping, so we have 2 errors. We have rounding, we have 2 errors. Also, this one, we have shopping, so we have 2 errors, rounding for each. So, like, see, for example, this example came in exam. This one. How many numbers? I have here 4 numbers. So you have to make normalized for 4 numbers. After that, check the method. For example, here I need shopping or rounding. So shopping, we have 1, 2, 3, 4. Rounding, we have 1, 2, 3, 4. Relative error, we have for shopping, we have also for rounding. Absolute error, we have for shopping, for rounding. Is it clear? And he just repeated the question. So again, don't apply directly the relative error or shopping error for result. This is wrong. For decimal form, at end of this lecture, again, decimal form in this one, or a float decimal form, normalized decimal form, it's 0.d. I have, like, this question came, by the way. I have 0, 1, 2, 3 masala. This is wrong. What I have to do, take this out. So it is 0, 1, 2, 3, 10 exponential minus 1. In this case, this is wrong. It must be number D. Abu Said got it? So shift out and add minus 1. This question came for example. Here, how many digits I have here? 1, 2. Here I have 1, 2, 3 digits. Here, how many digits? 3. This is minus 1 shifted. This question came for your friend. So I'm telling you, any question?